Hello and welcome to our talk, What's Up with Privacy? Privacy issue with instant messaging end-to-end encryption in the multi-device setting. My name is Tal A. I'm co-founder and CTO for Zengo. Zengo provides a very highly secured MPC-based cryptocurrency wallet. I have more than 2 decades of cybersecurity experience, for example, 9-time speaker at Black Hat, but this is my first time at USENIX WOOT, and I'm very excited to be here. So what are we going to talk about today? We'll start with explaining an intro, reminding ourselves how WhatsApp end-to-end encryption works based on the Signal protocol. Then we'll discuss briefly WhatsApp multi-device, and summing it up together, we'll see that when using conjunction, end-to-end encryption and multi-device privacy creates some issues. And we'll talk about how attackers may exploit this privacy issue and provide solution and direction for further research. So let's start at the beginning. WhatsApp end-to-end encryption. So WhatsApp has obviously great power. It's the third most popular used social platform and first form instant messaging app. It has nearly 3 billion users and probably crossed that threshold since that graph was made. And with great power comes great responsibility. And WhatsApp acknowledged that and introduced end-to-end encryption in 2016. It is based on the Signal protocol, and Moxie himself wrote the blog post about that in 2016. You have the screenshot on the right. And WhatsApp also released a white paper, updating a white paper that shows their current implementation of it. So let's remind ourselves a little bit about how Signal end-to-end encryption works in high level. Each user generates a private key and reports only the public key to the server, so the server does not see the private key. The server maintains the user key's directory, and when sender wants to send to receiver, it queries that directory in order to get that intended recipient public keys. And using these public keys, sender and receiver do extended Diffie-Hellman to create a shared secret, and with that shared secret, they can create a secure session and have end-to-end encryption. If we zoom in a little bit about what's going inside in more details in Signal protocol, so we can see the session key gets updated with each message, which provide both forward secrecy and post-compromise secrecy, which means that advanced attacker malware threat is within the threat model. Like, we are addressing Signal protocol address that issue and prevent, even if a malware is present on the mobile device, it can only do harm and decrypt session while it's on the device, not sessions before, and not sessions and not messages in this session before, and not messages in this session afterwards, because the keys is always updated in ways that the attacker cannot track if they are not present on the device. So let's sum up what the user got out of this end-to-end privacy upgrade. So before, access to servers gives the attacker access to all of the conversations content, and after, attacker needs access to client at the same time too, because on the server it's only you see only the encrypted version without the keys. So if, as an attacker, I need access to the device, then in order to get real content out of the server access, then probably there is no much use of that server access for that. Of course, server access still provides access to metadata, who talked to whom and at which times and so on, which is also important, but not access to content. And this secure privacy upgrade protects even against advanced attackers malware, which is very impressive, I would say. So we could be very content with what we have, but in InfoSec, we make pettiness our livelihood. And so there's this little pesky detail that small privacy leak created by this system. And the end-to-end encryption created a new identifier to the user device. It created now we have a public key that is strongly associated with the device, and we didn't have it before. And when user changes devices, they often change the public key, which means that users are notified that that's public key has changed, and they can and they need to verify it. So sometimes I see that you can see that too if you didn't turn off this feature in WhatsApp. And I see that message, okay, like your security code with X has changed. And I tell them, oh, congrats on the new device that you bought. I said, how did you know? And I said, well, I'm a hacker. I know such stuff. So there is that small privacy leak because ideally I shouldn't be aware of such changes in other people's setup. However, maybe this is a small, inevitable privacy price to pay to get all the glory of end-to-end privacy, as we showed in previous slides. Now, let's move on to another feature WhatsApp introduced, which is multi-device. As we saw, WhatsApp is gaining more and more users. So you have more users, you need to provide them with more features. Users expect WhatsApp to be available on every screen they have, not just mobile. So they want to have a web version of WhatsApp and desktop version of WhatsApp and so on. And of course, WhatsApp complied with that and provided such application. And in 2021, 5 years after end-to-end encryption, WhatsApp updated their architecture to support multiple devices. So how these different features work together, and we can also already see the tension because you have end-to-end encryption, meaning only one end talks to one end. How do you extend it to multiple ends? So the answer to that is Sesame algorithm to support multiple sessions. So the changes to the protocol is each device now generates a key, and as before updates the server and so on and so forth. So when sender wants to send to recipient, it needs the keys both for all recipients' device and also all of the other sender devices, because you want to keep a consistent view of the conversation, so other devices of the sender gets updated too. You need the keys for them too. You need to create a session with them. Of course, in most cases, that device that's actually sending device already established such connection before. So just to give a quick example, let's say Alice wants to send to Bob a message, and let's say Alice has 5 devices and Bob has 5 devices. So Alice sending device creates 5 sessions as before with all of Bob's device, and also has a session with all other 4 devices of Alice to update them with this message. So all in all, Alice sending device will send that message encrypted 9 times using the session key of this 9 sessions, 4 sessions to other Alice device and 5 sessions with Bob's devices. Okay. So more devices, more problems. So if you remember, we had a small privacy problem before. Well, now it got bigger because previously this scheme leaked the details of a single device. Now it leaks the details of all devices. So as a result, intended sender is aware of number of the receiver device and changes to them, because if the receiver changing its devices, then they get a new public key, and if I continuously monitor your keys, then I know you changed something in your setup. So what are the implications? Let's divide that in two. So for advanced attackers like think CIA, GRU, nation states, intelligence bodies. So it fits perfectly into the reconnaissance phase of the cyber kill chain model, which was coined by Lockheed Martin. It's a good reference for such attackers. So every campaign against their target, against advanced attacker targets start with reconnaissance. They learn about their target devices. So this fits perfectly because they can advanced attacker learn about their target setup, see how many devices it has and changes to that, and use device information to find the path of least resistance for the malware. So why go against the hard target of a fully patched iOS device when you can go as an attacker against a softer target of, let's say, Windows PC with or Chrome browser or something like that. But it's not limited just to advanced attackers. Okay, maybe you would say, I'm not a target of the CIA, maybe I shouldn't be worried. But also domestic abusers can abuse that. So think about jealous ex, suspicious spouse. This device information that is made available by WhatsApp, then suddenly you can get asked, why did you buy a new phone? Because your security code had changed, your public key had changed. And I can learn, or that domestic abuser can learn that, let's say, her spouse got linked a new device. So okay, so it's hard for me to spy over the mobile device because they keep it also always with them, but they linked it to the computer. So now I can log into the computer when they are not home and get the data. So it's also important. And domestic cyber abuser is indeed an important issue, as found by this Cornell study that we are linking to. So how would the attacker exploit that issue? One way to exploit is exploit with code, because the server provides all intended receiver keys and without a need to actually send. So this is very, very stealthy thing, because you say, I'm about to send to someone a message, so I need in advance having all of his keys, but then I don't actually have to send anything. So it's very stealthy. And it also means that including non-contacts can do it, can get this information, and even blocked users, which is kind of weird because they cannot actually send, but they are able to fetch that information in order to enable them to send. So remember that X, although you blocked him you blocked him and you cannot get messages from him or her, but still they can track your device information with this API. So there is an API to get all this information from the server. And so if you are handy enough with code, you can build your own code or use other people's code to get it. For example, use that great project by Ashoka University, I hope I pronounced it correctly, and they created an open source project with reverse engineering that enables everyone to use that WhatsApp web API and query the server in whatever way you want and build your own custom client. But we said domestic abusers are also a concern. So, and just to show that you don't need, you don't need to be handy with code or even buy this code from someone. You can also make it with already existing code that you have. You just need your browser for it. And let's use WhatsApp Web in order to get that information out of WhatsApp. And using developer tools, Chrome developer tools, or you can also other browser, I use Chrome, you can view the content of this table because this app stores its internal databases within the browser, and the web environment gives give the owner of the browser an easy way to look to view the content of the databases. So we use developer tools and go to Signal Storage Identity Store, and then we see all of our contacts devices ID, which is their phone number, and then some number is assigned to them, and also their keys. So, for example, I used that. I asked a friend of mine. I called him, look, I will tell you how many devices you have linked to your WhatsApp account. I said, go ahead. So I looked into that table and typed in his number, and he has like 4 different devices. So the one with zero, with just a 0, is always the mobile device, and then 3 other devices. This ID, I didn't find anything specific about that ID. It seems like just a running counter there. So obviously it seems like he had linked many different apps in the past, because it's already in 25. And he said, wow, you're correct. Indeed, this is a screenshot of his settings, and indeed he has 3 linked devices. It's 25, 26, 29, on top of his mandatory mobile device. And just to show you, it doesn't need to be really someone that approves of that surveillance. So I just took a publicly available phone number of a Hamas spokesperson and found out that I can see like he or they or whoever they may be is linked 3 different devices to their account, which of course I wouldn't be happy as a Hamas person to know that an Israeli guy can track what that device is set up. Anyway, we told Meta about it, the parent company of WhatsApp. The Meta acquired WhatsApp a few years ago, and they say, well, we acknowledge, we see your point, but we will not fix. This is how the protocol works. If you want to have end-to-end encryption, you must be ready to lose some privacy. And we think this is answer is wrong, because you can have end-to-end encryption and you don't need to suffer from such privacy leaks. So what will be a possible solution? One easy solution, which has many other security benefits, is introduce a lockdown mode. And with this lockdown mode, meant for highly targeted individuals, user can limit their exposure to contacts only, just like you do in other fields. Like you can see in the screenshot, you can set your status visibility just to your contacts. So if you do that, if you have that option, you can say, okay, I only want to receive messages, and as a result also be available to query for keys just from my contacts. And this is also can help with the exposure to 0 day, because it means no one, if you're targeted, let's say by CIA or GRU, they cannot send some invisible message to you with some zero-day exploit because you're not willing to accept messages that are not from your contact, and then it can be blocked by the server. So this can be a very effective solution that does not require deep protocol change and can limit the exposure of this issue to the user's contacts only, which probably it's good enough. A deeper solution would be to replace Sesame altogether. So instead of having multiple sessions, just have a single session in between sender and receiver, and would require solving the distributed algorithm challenge because you need now to maintain that state of the encryption. As we saw, each time a message is accepted, the ratchet advances and so on. So it creates some other challenges in the field of distributed system, but maybe this is a price worth to pay in extra complexity in order to gain some privacy and limit this privacy link. And there is a work from 2019 about it, and we are looking into it too, and we'll talk a little bit about it in the further research slide. So let's conclude. What remains for further research? So this issue of Sesame is not limited just for privacy. It's also an integrity issue because the sender is sending, as we saw in the example, multiple times and send differently encrypted message on different sessions on each device it has with the receiver. So the sender can send different messages and create a different worldview on each of the device. So we have a blog about that. And we also, as we said, we're working on multi-device without the device privacy issue. We have a blog post with a sketch for the solution available. And we're also working on further identifying devices type, not just saying, okay, this user has 4 types, and one of them is mobile, but also further identifying what kind of link device the user has. So let's sum up what we learned about today. We learned about WhatsApp end-to-end encryption, multiple device, and showed that together they create a great some privacy issues. And we've shown 2 ways how attackers can exploit this issue and even demo them. We suggested 2 solutions and some further research. So thank you for your patience and being here. And since this is a remote session, there is no Q&A session right now, but feel free to shoot me an email or DM me via Twitter. You have the details here. So thank you so much and have a great conference.